Okay, guys, so this is a more difficult example of finding and classifying points from critical points to whether it's a max, min, or a saddle point. All right, so here we have f of xy equals x squared y plus y squared minus 10xy plus 6. Okay, let's first find the first partial derivative. So if x is going to be, so we are going to highlight only terms that have x, and the other terms will be dropped out, okay? Because they are now y is a number. So x squared y is like a constant multiple, and derivative of x squared is 2x. So here we're going to get 2xy. This term will drop out. Negative 10xy, 10 is a number, y is a number, so this will just be 10y. And of course, 6 is going to drop out. Okay, so that's going to be your first partial. The second one, the fy, is going to be, I'm going to do the same thing, but only keep the terms that have y. Well, actually, that means that I'm also going to have to highlight this guy because the other terms also have y. So here we have x squared y, where remember x squared is like a number. So derivative of number y is the number. So that's just going to be x squared. Y squared derivative is like simple, that's just 2y. And then negative 10xy, the 10x is a number, so we keep that, and that's it. Now, the next step is to set both of these things to equal to 0 and see if we can solve for x and y. So here we have actually a non-linear system of equations to solve. So let me just substitute that to make sure. Okay. So how do we solve this? So this is a very, very important example because you guys are going to need to do something like that on the test. All right, so what you do is you look at one of the equations that seem to be easier and see if you can factor the GCF, okay? And that would be the first equation. So if I take the first equation and I want to factor the GCF, which is like, what do they share? Okay, what do these terms share? So I can see that y is shared in both, and also 2 is inside the 10, right? So I can take that one out. Okay, so let me take out the 2 and the y. And then in parentheses, I will have what's left from each term. So from the first term, x is left. And from the second term, when I take 2 out and y out, I still will have a 5 left. And then we use something called zero factor property. So this is something you should remember. The zero factor property is what I'm supposed to use to find my critical points. So zero factor property means that in order for an expression to make, which is a product of two things, two factors, if it's equal to 0, that means that either the first one is 0 or the second one is 0. So we are going to break this into two cases. Case number 1, let's make the first factor in the expression equal to 0. So when I divide both sides by 2, and hopefully you do understand that we're not subtracting, we're dividing by 2, so that'll give me y equals 0, okay? And then after I get that, I am going to go back to the first equation that I actually, no, the second, I'm sorry, the second equation that I ignored, and I am going to, until now, and I'm going to plug in y equals 0 into the second equation. So go into the second equation, not thinking that x is 5. This is one of those things that people mess up. You do not make x equal 5 and think that 5, 0 is your critical point. That is absolutely incorrect. Because yes, you will have the first equation will be 0 because both factors will actually be 0. But the second equation will likely not going to be 0. In fact, if you plug 5 for x and 0 for y, I am pretty sure that you're not going to get a 0 from the second equation, right? And remember, critical point, in order for it to be a critical point, it must make both fx and fy equal 0. It cannot be just one of them. So here you do one or the other, either 2y equals 0, and then you use the other equation to solve that for either x or y, whichever one, or the second part, which is x minus 5 equals 0, and again you use the other equation. So now let's go back to the fy equals 0. So x squared plus 2y, and y is 0, minus 10x equals 0. Now, how do I solve this? So this is another zero factor property because these two things have a common factor, which is x. When I factor it out, I will get x minus 10. And again, I have two factors that I could separate and say, okay, either x equals 0 or x minus 10 equals 0, which corresponds to x equals 10. So from here, I'm going to get two critical points, 0, 0, because remember y was 0 and I just got x equals 0, or x equals 10 possibly, and then y is also 0. So far, these are my two critical points that I found from case 1. Now let's go back and decide what's going to happen with case 2. So let's go back to that zero factor property which we said. Either this part is equal 0 or x minus 5 equals 0, which is case 2. And that's going to give you x equals 5. Okay, so if x equals 5, you have to go to the other equation, which was number 2 equation, and you gotta plug in x equals 5. So I'm just looking over here on my left side. So when I plug x equals 5, I'm gonna get 5 squared plus 2y minus 10 multiplied by 5 equals 0. Okay, so 5 squared is 25 plus 2y minus 50 equals 0. Now that is 2y subtract 25 equal to 0. So I got y equals 25 over 2. So my critical point is 5/25. Now, whether that's right or not, I'm going to determine that in just a second because I am going to check it. So what should happen? So check for each point. So even though it takes a long time, you must have fx at the first point, which was 0, 0. You have to check, is that 0, yes or no? Then you have to move on to fy and check it for 0, 0. Can you believe that? Yes, absolutely, I have to do that. Then I have to go to fx again and do the other point, which was 10, 0, and see if that's equal 0. And I have to do it for fy and plug that in there and see if that's equal 0. Now what I'm going to do with that suspicious fraction thing, the 25 over 2, I hope I got that right, and that has to be 0. And also for fy, that is also supposed to be 0. And if it's not, then I'm going to start crying because I get that wrong. Okay, this doesn't look like a 2. Okay, so let's start using the calculator. So I've got my calculator here ready. Okay, so this is 0, this is 0. Let me just recheck it. Yes, okay, so this is correct. Okay, that's good. Now let's check the last point. So we got, that was close. Okay, so both of these are correct. And then now let's go to this one. Okay. Okay, great. So we also checked this one. So now we know that we got our 3 points and they are correct. Now, when you list them here, you want to order them from the smallest x value to the largest. So I think the first one would be 0, 0. Then the next one would be 5/25, and the last one would be 10, 0. Okay, so now we have to find the second partial. So let's go ahead and do that. So we are going to take this one and take the derivative of it with respect to x. Now only 2xy has x in it. The other term will drop out, and that derivative will just be 2y. Now again, I go back here and find the derivative with respect to x this time. So this is going to be 2x minus 10. And finally, this one, fy with respect to y. So that's easy. That's just going to be 2. And basically also just to double check, if I take the derivative of this with respect to x, that is 2x minus 10, and that should match this one because the mixed partial should be the same. All right, so once we got that out of the way, let's go ahead and define all our second derivatives in Desmos. So hopefully I'm not going to mess up this time. This is supposed to be, doesn't like it because it's supposed to be xx. So remember to use that underscore, right? Which is like a shift minus. 2x minus 10, and let's do yy. So next we're going to define that d number, which is going to be fxx multiplied by fyy subtract fxy squared. So don't forget to square. Otherwise, you might get a negative d or something, which should not happen. Okay, so this one is negative 100. All right, let's do this one. That's 50. And finally, 10, 0, we got also negative 100. Okay, so this is supposed to be negative 100. Okay, so whenever d is negative, we immediately already know it's a saddle point. But we can't classify that one yet because we need the fxx value. So unfortunately, they ask you fxx value even though you do not need it for the saddle points. But they can't give you a hint whether you need it or not. So you're gonna have to fill this out. And so fxx for the bot at 525 halves. That one's more important. Oops. So that one's 25. And if I want to also find fxx at 10, 0, which again, I do not need because I already know it's a saddle point, that is just going to be 0. All right. So to classify this other point, we're looking at D, and D is positive. And fxx is also positive, which means this is going to be a minimum. It's kind of bad that I haven't had a chance to look at the example when it's maximum. So maximum is when D is positive, but that thing is negative. So if that happened, that would have been the maximum, but in this case, it's not. So this is going to be a minimum. And then the last thing is what they want is basically determine the the z coordinate of each of these points. Like where is it located on that surface? So for that, I actually have to enter the regional function into Desmos so I can plug in the points. So f of 0, 0, so that means that point is going to be a saddle point. If I do this 525 halves, I do not know if they want a fraction, probably, so I'll just put that in there. And f of 10, 0 is going to be 6. Okay, it does not like it because I did not type it correctly. Now, the last thing that I actually wanted to show you was what would have happened if I were to graph this thing, right? So I am going to see if I can enter this function in my Calplot3D just to double check and make sure that it looks okay. So let me just insert that. And probably the z values are pretty high, right? I'm not sure what the 600 over 4, that's going to be really hard to graph. So I'm really going to have to mess with the z scale. So I'm just going to see if I can put it like negative 500 by 500 and make it tick to be 100. And let's see if that helps visualize it. No. Okay, so this does not look good. Yeah, this is not a good thing. So I really have to get closer to it. How about 10? Okay, that is already better. That's better. Because I'm trying to figure out if 0, 0 is really a saddle point. It does look like it, right? Because 0, 0, if we go to that 0, 0, 6, if we insert a point, so let's go from formatting axis and just insert that point. So it's going to be 0, 0, 6. That should be that saddle point, right? And you can't really see it. I'm going to make it a magenta. Okay, it does look like that's a saddle point. It definitely looks like it. I do not think I'm going to be able to see this other point. Well, I can see 10, 0, 6, maybe, but I have to mess with these. Let's see if I change this to that. So can I put the point 10, 0, 6 and see what that is? It's kind of hard to see. It's supposed to be a saddle point, right? Because like it's supposed to be from one side max and from another side min, and it looks like that's what it is. And then the 525, that one I do not think I'm gonna see because this thing it has a very small z, so that should be like dip to a minimum. I think that that's what it's gonna be. So if I would try to graph it, I don't think it's gonna work because it's not going to show it to me, right? Like it's going to be over here. So I really have to mess with the z-scale to see it. Maybe even, yeah, but then this one is not. Yeah, okay. So now you can see that there is your minimum right there.